Hello and welcome to another tutorial of ProfLearn YouTube channel. In this particular video, we are going to have a discussion of this prediction of the January paper of Thursday 19th, 2025. So this is the alpha prediction, which will mean that the beta prediction will be coming. So I'll be having a series of two predictions, alpha prediction and beta prediction for P1 math of AF of January 2025. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. So let's dive in and see the question that I think that you really need to prepare on as far as your P1 Math 1 P1 is concerned. So the first question that I've set here is a question from SADS. So as you are preparing for your exam, you need to prepare on how to answer questions to do with SADS, and that is rationalizing the denominator. We are told that write 8 minus, this is given as 8 minus SAD 15 over 2 SAD 3 plus SAD 5 in the form A SAD 3 plus B SAD 5. So what you need to do at this point of time, you need to multiply the numerator and denominator by their conjugate. And remember the conjugate, when we were learning this, we said we only change the sign of whatever that is in the denominator. So this is going to be 2 root 3 minus SAD 5. We multiply it at the top and at the denominator. And you can see now this is going to reduce to this. So as you are preparing for your exams, remember to prepare on how to answer questions to do with SADS. We are told hence otherwise. So meaning hence otherwise questions, it means whatever you had gotten from the previous section is going to be very helpful for you to work out the second section. Plus 5 SAD 15, right? Because you are having the SADs, those with the SADs are going to be multiplied. So you multiply 3 and 5. And then this is going to be equals to 40 minus 2x 33. Now at this point of time, I'm going to take those terms with x on one side, so I shall have x 5 plus plus x 5 plus 2x 33 is going to be given is going to be equivalent to 40 minus 5 SAD 15. Now, if we factor x out here, you can see that we are going to remain with what? We're going to remain with SAD 5 plus 233, which is equals to this one. If I can factor out 5, I'll remain with 5 into 8 minus SAD 15. I can divide both sides by root 5 plus 233 35 plus 233. Now something I need to make you aware of, we are going to remain with our value of x that we are solving, and this is going to be 5 into 8 minus SAD 15 over 233 plus SAD 5. Now I want you to look at this equation that we are having here, and the equation that originally that was given. The SAT that we are having, the SAT that was given, or the question that was given was 8 minus SAT 15 over 2 3 plus root 5. And that is exactly what we are having in this particular section. Yeah, this is what we are having in this section. Yeah. So which means that we can be able to use the solution we got in the previous. So our x is going to reduce to, because this part that we had done, here, where we had gotten an answer, the previous section 333 minus 235. So you can say this is going to be 5 into 333 minus 235. And that is going to be equivalent to 15 33 minus 1035 as the value of x. So the second question that also you need to really be ready to work out is a question to do with discriminant. There is something that we had learned about discriminant. We had said that if you have a line, if a curve and a line meet at one point, then we're going to say b squared minus 4ac should be equals to 0. The discriminant should be equals to 0. But if they are meeting at two distinct points, we're going to say that the discriminant is greater than 0. Have a curve and a line meeting. If they are meeting at two distinct points, then say that the discriminant. So if the line does not meet, then there is no solution. Then we can say discriminant less than 0. So these are the key areas that you. Now we are told that the equation here, 4 into p minus 2x equals to 12 plus 15p over x plus p, where x is not equal to negative p. Remember, we were told that that's a condition for this function to be valid, because if p is negative 1, then the denominator will be 0, and the function is going to be undefined under that situation. Where p is a constant, has two distinct roots, then it means that the discriminant here is going to be greater than 0. Then we're going to multiply both sides, and we shall form now a quadratic equation. We're going to multiply this denominator here, both sides, then we're going to form a quadratic equation. And our quadratic equation here is 8x squared plus 4px into 12 plus 15p minus 4p squared. The whole of this is a constant, and that is the value of our c. Then we shall say now, because it has two distinct solutions, we are going to say now these distinct three roots, we're going to say the discriminant is going to be greater than 0. So remember, discriminant is obtained by b squared. Our b is 4p. So we shall substitute. And then once we work it out, we're going to get our equation like that. The next thing that they are telling us is to find the range of possible values of p. So you are going to solve this quadratic inequality. And remember, to solve this quadratic inequality, you are going to treat this as an equal sign. First, you treat the quadratic inequality as the equal sign, so that you get the value of p and the value of p. Then you are going to sketch that on a number line. And remember, we are talking of the quadratic greater than 0. If it's greater than 0, it means we want of the curve on the upper line of this, want this upper line. So meaning that the values of p that satisfy the upper line are values sides, shown in, and the value that satisfy this section of the line here, values of show this part. So it's when P is less than -2/3 or P greater than 4, and that becomes the range of values of function. The next question that you really ought to know also is how to work with finding area of a sector in radians, finding the arc length, and the basic principles and the basic formulas that you ought to have in this is that area is equals to a half area of a sector. For instance, if this is a sector and this is the angle in radians, then it means that area of this sector is going to be a half r squared theta. But if you are, because if this is the radius and this is the radius, then we can say that is the area of the sector. If we are talking of the arc length of this diagram is going to be equals to r theta. And remember, we are using these formulas whenever we are talking about um, sectors and arc length. Area of a sector or area of arc length of arc length rather, yeah, when you are given the angle in radians. Then also remember another formula that is very important for you to be which you will be using mostly topic is area of a triangle. If you have a triangle and then you are given one of the angle, you can say area equal to half AB sine D, whereby A and B are the sides that are forming that angle. Don't forget cosine rule, and also don't forget sine rule in this particular topic as you have. Now let's look at main question. We're told the figure shows the plan of a garden. OA and CD are perpendicular to OD. Okay, so let me just read. AB is an arc of the circle with center 4 and radius of 4 meters. BC is parallel to OD, and we are told OD is 6 meters. The dimension here is 6. Show that the angle A or B is 1.86. A or B, this angle here, that's the one that we are trying to show. We're trying to show this angle, that. So we know that angle A or D is actually 100 and we know that the entire of this angle here is 90 degrees. So meaning what we only need to find is this angle. Then once we find this angle, we can say 90 minus this angle, we shall get this one. But this is a right angle triangle here. So meaning we are going to use SOHCAHTOA because we were told this is the radius 4 centimeters. Also, it means that this radius here, this distance here is also 4 centimeters. So using SOHCAHTOA, and then we use the opposite and the hypotenuse. Opposite and hypotenuse, basically, which part is that? Using opposite and hypotenuse, that is sine. So we shall say sine 1.5/4 is equal to that. We ensure your calculator is in radians. Now, once you have gotten that, you can be able to the answer you have gotten, that is 0.5 pi, because 90, this is 0.5 pi, and we are saying 90 degrees simply because the angle that we're having at this point 90, yeah, angle that we are having, the whole of it, A or D is 90. So since we have gotten this angle here, then we can be able to proceed and work out Yeah, so 90, that is 0.5 pi minus 0.3844. Then we get 1.18. Now find the perimeter of the garden. Remember, to find the perimeter, first we need the arc length of AB. Arc length AB, need this section here. And that is going to be what? Pi, no, that's going to be r theta. So, and our r is 4 times the angle which we have gotten, 1.18. That becomes 4. Answer becomes here 4.74. And then we need to find OX. How are we going to find OX? OX, and I've just said OX is, and I identified OX from here, because we know, yes, from this point to D is 6, but we need OX. OX, we can be able to use Pythagoras theorem. This and this one, we get this distance here. Then once we have gotten that 6, which was the length, the entire length, 6 minus the answer we get, in order to find what this section is, rather this section we need, so that we can be able to find what this section is, so that we can be able to also include it when we are finding the perimeter. Then we add the 6, then we add the 4, that we can be able to get the perimeter being equivalent to what? 18.5 meters. We're supposed to find the area of the garden. Remember, we can be able to find the area of this. Just remove everything here, because everything has become so messy. I can be able to find the area of this trapezium. If I find the area of this trapezium and then add the area of this sector, then I'm done. As simple as that. So we know that this, we have already gotten what this distance here is, and then we can be able to apply area of a trapezium is half h into a plus b, where this will be our a and this will be our b, this will be our h. So substituting that into the formula, we're going to get the area of the trapezium being 6.21. Area of the sector, we said, is a half r squared theta, or theta r squared, which I got as 9.49. And then if I add the two, I'm going to get a total of 15.7 meters squared. In question number 4, we are talking about functions, and then we are told that f of x is a quadratic expression. C1 has a maximum. C1 has the equation y equals to f of x. And we are told that this f of x that is being referred to is a quadratic expression. C1 has a maximum turning point. Remember, now from completing square method, we can be able to get this. And C1 passes through the origin, passes through this point. So due to that, I was able now to come up with how that graph is going to look like. This becomes our turning point. The graph will up and down, because you see you cannot have a turning point here and then you have the point where the graph is passing. That's how the graph is going to be looking like on the graph. And then we are supposed to write that in a complete square form. I decided that I don't know what this letter outside here is. I just placed it minus 2, because whenever you are finding a turning point, usually you take the opposite sign. So since our turning point was positive 2, inside the bracket here, therefore we shall have minus 2. And then now, in order to find the value of a, I substituted the origin 0, 0 into this equation, so that I was able to find my value of a as -5. And now our f of x can be written in that form. Yeah, the next question was that using algebra and showing all your stages of your working, find the coordinates of P. Okay, in the beginning, let me just give you the detail that were provided here. C2 as the equation this. curve C1 and C2 meet at the origin and at the point PQ. So, given that x coordinate of the point P is negative, using algebra and showing all your stages, find the coordinate of what? P. So if they are meeting, then we are going to equate the two. So we are going to have x into squared minus 4 is going to be equals to what? 5 into x minus 2 squared. Now, opening the brackets of every plus 5 so we are going to factor 5x, so meaning that x going to be 4 or plus 5. So if you solve and this equation factorize about factorization, so we so our x or objective. So we are told that P has a coordinate of P for which value of negative having therefore x value of, and if we want to find the value of y, this is going to substitute into n of the equation, n of the work it out. Let's check what that becomes. We are told that curve C has the equation y equals to f of x, whereby x is greater than 0. We are given the gradient function f prime of x to be 4x squared plus 10 minus 7 x raised to power a half. over x raised to over 4x raised to power a half. Then the point P, which is 4 negative 1, lies on C. We're supposed to find the value of the gradient of C at P. And remember, to do this, we only need to substitute the value of x, which is 4, into this gradient function. So we are going to write the gradient function, and then we shall substitute anywhere we have x, we shall be substituting 4, and then we simplify that, which is going to reduce to 15 over 2 as the gradient of C at P. In Roman 2, hence find the equation of the normal. Remember, a normal forms a right angle with tangent. So which means that we need to use m1 times m2 in order to get the gradient of the normal that we shall be using. Then this is what I'm saying. If you have a curve at P whose coordinate is 4, negative 1, then this tangent will have the same gradient that we have obtained here, which is 15 over 2. But a normal forms 90 degrees with this tangent, so this is the normal. Then if we want to find the gradient of the normal, we're going to say the gradient that we have obtained times m2 is going to be negative 1. So if you work out that, you're going to get negative 2 over 15. Then using the coordinate that was provided and y equals to mx plus c, we can be able to find the value of c as negative what? Negative 7 over 15. Then we can be able to substitute the values into the equation of a straight line. But remember, the equation of the line that we were to find has the form ax plus by plus c is equals to 0. So you cannot be able to leave your answer here. Be very keen how answers are supposed to be stated as far as your question is exam is concerned. So here we are going to multiply by 15 all through, and this is the correct format that we were supposed to get for this. The next part is to work out find the gradient, the function f of x. Remember, we were given f prime of x. To get f of x, then it means we are going to do integration. Now, before we integrate, we need to rearrange this equation that we have here so that it's simplified, so that we can be able to perform the integration that you've learned in P1. So this one need to come down here. And that function f prime of x is, we can be able to write it this way, so that we can be able to begin the integration term by term. Integrating f prime of x becomes y, or f of x. So we shall now increase the power by 1, then the new power divide it down here. This is 5 over 2 x raised to power negative 1 over 2 plus 1 over negative 1 over 2 plus 1 as well. Then this is minus 7 over 4. Since it's a constant, we add an x, and then we shall say plus c. Plus c at that point. Yeah, so this is not a minus, it's plus. I don't know why the ink has jumped on that, but that's plus c. So substituting everything that we have into this equation, remember we have p, which is 4, negative 1. Then you can be able to substitute everything into that equation so that we can be able to value of c in here. And the value of c is going to translate to negative 4 over 5. So our new equation now becomes plus negative 84 over 5. So this becomes negative 84 over 5, like that. We are supposed to sketch the graph of y equals to 6 over x, where x is not equal to 0. Then this is a graph that will behave like this, and this point we have the x-axis to be the asymptote, and also the y-axis is the asymptote. And then we are going to fully describe the transformation that maps the function that we were having to y equals 6 over x minus 2. This is actually a translation 2 units to the right, 2 units to the right, parallel to the x-axis, right? Okay. Moving to the next part of the question, part C, let's see what it has for us. We are told that given that the curve with equation y equals to 6 over x minus 2 and the line with the equation y equals x kx plus 7 intersect exactly 2 points at P and Q. So if they are intersecting 2 points, we are going to start thinking about the discriminant. Given that x coordinate of P is -4, find the value of K. Yeah, find the value of K. So we know that x is -4 because we have been told the x coordinate of P is -4. So this -4 we can substitute it into this equation that we are having here, y equals to 6x minus 2, so that we can be able to find the value of y, and our y is -1. Then we go to the second equation, we substitute the value of y -1 so that we can be able to find the value of k. Okay. And why are we doing this? Because the two lines are intersecting. That's why we are doing that. So find using algebra the coordinate of q. So already we have the value of k. We have the coordinate of the value of x for p, which is -4. So we need q. And we are also have the equation. So meaning that we are going to equate the two equations like this. And then we shall say 6 over x minus 2 is equals to k x plus 7. But do we know the value of k? Yes, it's 2. Then plus 7. Then multiply both sides by x minus 2 so that we can be able to expand this equation that we have here. If you expand, you're going to form a quadratic equation which we are going basically to solve. Now, solving this quadratic equation, what are we going to get? We are going to have it factorized to this. So we have x is equals to 5 over 2 or x equals to negative. Because already one of the coordinate -4 has been used, so meaning the coordinate of q is going to be 5 over 2. That's the value of x, 5 over 2. Then we can be able to substitute into the straight line so that we can be able to find the value of y. So the coordinate of q should be having y, x and y. So our x is 5 over 2 and our y for q 12 as obtained here. So what does that mean? You need to know how to work out questions like this involving a curve and a line intersecting. You need also to remember something to do with discriminant. Inequalities also another area that you need to remember. Let's look at the figure which shows part of curve C with the equation y equals to f of x, and f of x is given as 2x squared minus 12x plus 14. Now we are supposed to write it in the form a into x plus b squared plus c, right? So which will mean that we need to complete the square here, and to complete the square is something that you really need to know. So our equation is given like that is 2x squared minus 12x. We can factor 2 out in the first two terms so that we can say plus 14. Then whatever that is inside the bracket, we are going to complete the square of that. So we shall take x minus a half of 6. 6 divided by 2 will give you 3. So we shall say minus 3 squared minus the square of this number that is inside this the bracket, that is x minus 3. So minus the square of negative minus the square of 3. Don't consider the sign. Even if it was a positive inside the bracket, we are supposed to subtract always. Okay, then now we can be able to open the bracket. Since 3 squared is 9, and then there is a 2 outside the bracket, so that will be minus 18 plus 14, and that simplifies to negative 4 at this point. Okay, so this is the form that was expected, and if you are supposed to state the values of a, b, and c, these are the values that we were to show. A is 2, b is negative 3, and then we have c equals to negative 4. Given that c has the minimum point at the point, as a minimum at the point p, so meaning that is the coordinate. P coordinate will be negative. Since it's a negative on the completing square part, we have x minus 3. So when you are picking the x coordinate of the turning point, you're going to say positive 3. You take the opposite sign, and the outer one for y, you take it the way it is. Yeah, this negative 3 is the only one that you are going to switch. You are going to switch the sign of the x value. The line L intersects C at negative 1, 28, 28. P and P are shown there. So we have seen how the two lines intersect. Find the equation of L given. We were having, these are 2 points where the straight line is passing. It's passing through the point P and the point whose coordinate is negative 128. Then it means that this being a straight line and you have 2 coordinates, for you to find the equation of the line, you just need to find the gradient of the line. And the gradient of the line is change in y over change in x. So we can be able to assign this to be x1, y1, x2, y2. So we can be able to substitute here in the process of finding the gradient. Then we shall have our gradient translating to negative 8. Yes. Then now we know that the equation of a straight line obeys this text form, and we can be able to use one of the coordinates, substitute the value of y and x, so that you can be able to find the value of c, and our value of c is going to translate to 20. Now we can be able to write the equation in the form that was expected. We are supposed to define all, use the inequalities to define the region R. Let's go to the diagram and then try to define that region. So this equation here that we're having is y equals minus 8x plus 20. So the inequality defining the region here will be y is less than negative 8, x plus 20. And for this other curve, we are going to say that is f of x is greater than or equals to x squared minus 12x plus 14, right? And then we have the coordinates where these the range of the values of x, basically you can see is from 0 all the way to where this line is cutting the x-axis. I also decided to include those coordinates so that we can be able to fully give the inequality that satisfy the shaded region. Now, up to that point, I think we need to switch to the next question. And in that case, of course, let's find the x-intercept, that's straight line, which is going to be basically 5 over 2. And I now say the inequality here is x is less than 5 over 2, greater than or equal to 0. Yeah, so those are the inequalities that satisfy the region that was shaded at that point. So we need to move to the next part, and I believe this next part is also going to involve more of inequalities, but we are going to learn some new concepts that maybe can be very helpful in your exam. We have the region shaded, and then the region R1 shown shaded in the figure 2 is defined by the inequalities. The inequalities are well stipulated here, and we can see here y is equals to kx. K is the gradient. I want you to understand from the word go that k here is representing the gradient of this line. And then we have the line which is y equals to 2, so meaning is a horizontal line that has the y-intercept of 2. So we can say this coordinate, how can we be able to write these coordinates? K, all right, k x equals to 2, because this one they are meeting somewhere, right? Yeah. Okay, let us just leave it that way. We have this coordinate. This is a, x equals to a vertical line. All right, so meaning this coordinate here is going to be a comma 2. That's first coordinate is a comma 2, because we have x equals to a, so a comma 2. Then we need to find the second coordinate, which is the origin 0 0, and this is the third coordinate here, which we can be able to, you see, this is the line y equals to 10 minus 2x, and it's intersecting the line y equals to 2. So where we have y, we can be able to substitute 2 and then try to find the value of x at that point. So solving, our x is going to be 4, but y is going to be 2. Then we have another coordinate here, which is going to be what? The x, the y value for this coordinates is actually 0, because this is the x-axis. So we can be able to substitute 0, and when you substitute 0 here, we're going to get the value of x being equal to 5. And this is how I got it. I said y is 0 equal to 10 minus 2x. Yeah, then 2x divided by 2 both sides, our x becomes 5. So that is it. Now, if you look at this question that we are talking about here, we were told that given that the area of R1 is 27 over 4 square units, the area of R1 is 27 over 4 square units. So we are supposed to find the value of A and the value of K. Now, in order to find the value of A, let me just bring to your attention that you can be able to find the magnitude of the dimensions of that trapezium. Then you apply the area of the, or you apply the formula of the trapezium to get it, and you equate it to 27 over A. Or you can be able to use the coordinates that we have obtained. Using the coordinates that we have obtained, we can use shoelace method. I want to bring to your attention about shoelace method. Shoelace method is a method you can be able to find the area of any polygon or any shape, provided you know all the coordinates of that shape. So whichever shape you have, so long as you have the coordinates, you are going to apply shoelace methods. And then if you are multiplying in that direction, you are going to take positive, and you are going to multiply in that direction, you are going to have negative. I'm going to show you what it means by that. Now let us go first and write the coordinates where, according to shoelace method. Shoelace method states that A is equals to a half. Then you write the absolute sign and write the first coordinate as A vertically, A2, A2. Remember, we were having the first coordinate there, A comma 2. So we are going to write it as we are going to write it as a position vector, A2. The second coordinate is going to be 4, 2. The third one is 5. Yes, the third one is 5, 0. And then we have 0, 0. And you must close with what you started. So it should be A2, and then have the absolute, absolute, absolute. or modular sign like that. So the modular sign is states that if you are going to get the answer negative after performing this shoelace method, you are going to assume ignore the sign. So you take only positive values because area cannot be negative. Now, according to shoelace method, I said there's an arrow. This arrow that is red indicates positive. The arrow that is yellow indicates negative. Let me show you what I mean. So we are going to write it multiply 2 times 4. Okay, it will be a half, then modular sign. 2 times 4 will give us 8 plus 2 times 5 will give us 10 plus 0 times 0 will give us 0. 0 times a will give us 0. We close the bracket. We are done with that. Then now we are going to subtract. Yes, after that you subtract. It will be a times 2 will give us 2a. 4 times 0 will give us plus 0. This will give us 0 and this will give us also 0. Then we close the bracket with the modular sign both sides. So we are going to end up having 18 minus 2a. So this is going to be equal to the area that we were provided times 2 both sides. And then we are going to multiply again by 2 both sides so that I have 36 minus 4a is equals to 27. Solving for a, our answer is going to translate to what? 9 over 4, like that. So that is how we apply shoelace method. The key area to remember when you're applying shoelace method is the way you multiply. And that's why I've decided to use different colors so that you can be able to see how you go about it. Now, here we are. We have the value of a. And this value of a is 9 over 4. So meaning that we can be able to find the gradient of this line whose equation is y equals to kx. Remember, k is the gradient. K is the gradient of this line, so we can be able to use rise over run, and k is going to be changing y over changing x. So you can see where, for instance, the point where the equation x equals to a or x equals to 9 over 4, and where the equation where it's meeting y equals to k plus x is that coordinate a2, right? We can be able to find the gradient of this line. So that will be 2 over 9 over 4, and that's going to be 8 over 9. So the value of k is going to be 8 over 9. So let me just transfer this part down here where the working was supposed to be, and just having everything well arranged so that you can be able to learn that you need to arrange your work properly to make it easy for the examiner to see your work and earn your marks. Remember, when you are arranging your work well, there's no extra mark for that. That's just meant to make the examiner happy and to be in a good mood of marking your paper, and then he's not going to be very mean on you. Okay, so define the region R. Also using the inequality, define the region R2. Define the region R2, also shown shaded in the figure 2. So yeah, let's go and try to see those inequalities that we can find here. This is the region R2 that this examiner is talking about, and this equation is this, and this equation, remember, we have gotten x is equals to 9 over 4. So the inequality here will be y is greater than all equals to 8 over 9x, and x is greater than, because this line is basically dotted, so we're going to just say greater than, yeah, like that, right? So basically these are the inequalities that you are supposed to identify in this particular question. Now we are moving to trigonometry. Is another area that also you must know how to approach. And before we move to trigonometry, I need to bring to your attention a few key areas you need to understand in this topic. And that is to say, if you are given a function y equals a sine bx, or you are given y equals a cos bx, then it means that a is the amplitude for that kind of functions. And if you are asked to find the period, you are going to say 360 or over b, or 2 pi radians over b if the angle was in radians. So that is giving us the. Now for tangent functions, for tan, for instance, this one, the period is not going to be 360 over b. No, it will be 180. Period will be 180 over the value of b, or pi over b. But if you are maybe finding the asymptote, where the asymptote will be, this is the formula you shall be using, and you are going to get a question whereby you are using this in the next video. So that is in the beta prediction. You will check it in the description so that you can be able to see how you use this kind of now the curve C1 cuts the positive axis at the point P270 as shown in the figure. State the value of n and state the period of C1. Now, look at this graph that we are having. P is a quarter a cycle. Remember, a complete cycle gives a period. So P is a quarter a cycle. So we can be able to say this because we were told that P is 270, then it means if a quarter cycle is 270, then what will be the full cycle? Because we have 4 quarter cycles in a complete cycle. This will be also 270 at this point. 270, and then that will be 270 plus 270, that will be 540 plus 270 here, and then we shall have plus 270. So then we shall have 1080 at that given point. So for instance, so since we have said that 1 quarter is 270, then if you multiply 270 times 4, that will be 1080. So 1080 is the period of this kind of function. And in order to find the period, remember we said it's 360 over the value of b, but our b is 1 over n in this case, and that is our period. But our period is what? Is 1080. So we can say this is going to translate to what? This, our value of n is going to translate. Now, if you can look at this part that we are having here. From this point, from here to here is 270, 270, 270. This mark will be a full period, which is 1080, and plus 270 plus 270 again. This one will be 1620. And since the amplitude here was 3, then it means Q is at the lower part of the graph, so meaning this is going to be minus 3, and the coordinate for Q will be 1620, negative 3, like that. And say 270 times what? 1, 2, 3, 4, 5, and 6. That is the one that is giving us 1620. And since Q is the minimum point, is going to be negative 3. So the coordinate for Q is going to be given as 1620 degrees, comma, negative 3. C, we're to the curve C2 as equation y equals to 2 sine x plus k. We are given a point R whose coordinates a 12, 5, and another point S whose coordinate is negative a, negative 3 over 5. Both lie on this equation. So if remember you are given maybe a straight line and you are told that this curve passes through the points, you can be able to substitute them in. So in order to find the value of k, we are going to substitute RA 12 over 5 into the equation. And upon substituting that, we are going to form the first equation here. This is our equation 1. Substitute S also into the equation, and then we are going to form another equation, which is going to be this. But you need to remember that sign negative A is the same as negative sign positive A. Then the second equation now becomes this. So once we have this, we are going to solve them simultaneously. Solving this, we're going to get the value of k being equal to 9 over 10. And basically, that's what you are supposed to do in that particular question. If you have gotten value from this video, consider subscribing so that anytime I'm going to upload the next prediction, you'll be notified. You can check that alpha. This was the alpha prediction, so you will check the beta prediction in the description down below. Remember to share this video to your friends who can also benefit, and subscribe, and also leave a comment how you find this prediction. 3